Hi, welcome to Academic Math. Today I will solve exercise 2 of the book Higher Algebra by SK Mapa. This exercise is basically on the relations on sets, and in this video I will solve 4 questions of question number 1. And in question number 1 we have to determine the nature of the relations row which is defined on Z. Row is defined on Z set of integers by egg number number 1. A is related to B if and only if AB belongs to Z and A less equals B. We have to determine the relations, determine the nature of the relations. We have to determine the nature of the relation row on Z. That is, we have to find row is reflexive, symmetric or transitive. Here we can say that, so the first step, that is the to check the reflexivity, let A belongs to Z, then A is less equals to A for all A belongs to Z, which implies A is related to A for all A belongs to Z, which implies row is reflexive. So row is reflexive here. This is our first observation. Now I will show that row is symmetric or transitive. I will check row symmetric or transitive. To check the symmetricity, let A is related to B, which implies A less equals B, but which does not imply B less equals A. Hence A is related to B does not imply B related to A. Therefore, we can say that row is not symmetric on Z. To check the transitivity, let A related to B and B related to C, which implies A less equals B and B less equals C by the definition of the relation which is given in the question, which implies A less equals C, where A, B, C are elements of Z, which implies that A is related to C. Hence A, B, C belongs to Z. For A, B, C belongs to Z. For A, B, C belongs to Z, A related to B and B related to C both implies A related to C, and therefore the relation row on Z is transitive. To check the antisymmetry, let A related to B and B related to A, which implies A less equals B and B less equals A. Now, by the theorem of inequality, by the properties of the inequality, we can say that A equals B. If both holds simultaneously, then we can say that A equals B, which implies that A, the relation rho is antisymmetry, is an antisymmetry on Z. So we have find the nature of the relation rho on Z in the first question. So we have finally get that we have seen that rho is reflexive, rho is not transitive, rho is transitive but not symmetric, rho is not symmetric, not symmetric, rho is transitive, rho is an antisymmetry. Rho is an antisymmetric. Rho is an antisymmetric. This is the nature of rho for the first question. Now, in the next question, it is question number 2 of question 1. I will check the nature. I will determine the nature of the relation rho is defined, where rho is defined on Z by A is related to B if and only if AB is greater equals 0. Now, to check the reflexivity, let A belongs to Z. Then A into A, which equals A square and which is always greater equals 0. So which implies A is related to A holds for all A belongs to Z, and therefore rho is reflexive. Rho is reflexive. Now in the next page, I will check rho is symmetric or not. To check the symmetricity, let AB belongs to Z and A related to B, which implies AB greater equals 0, which implies BA greater equals 0. Since the multiplication of two numbers is commutative on Z, since Z is commutative by the property of commutativity of the set Z, we can say it, or we can say that since in Z AB is BA. We all know that the product to numbers, to arbitrary integers, are commutative in Z, which implies B related to A, and therefore A related to B implies B related to A for all AB belongs to Z. Hence, rho is symmetric. To check the transitivity, let AB C belongs to Z such that AB such that A related to B and B related to C, A related to B and B related to C, which implies that AB greater equals 0 and BC greater equals 0, but which does not imply that AC greater equals 0. Why? For example, if let A equals -3, B equals 0, C equals 2, then 0 -3 into 0 equals 0, and which is we can say that which is greater or equal to 0, that is A related to, that is -3 related to 0 holds. -3 related to 0 holds, and B dot C, B means 0 dot C means 2, which equals 0 and which is again greater or equal to 0, which implies that 0 is related to 2. That is, in the previous page we have seen that -3 is related to 0, and in the next page we have seen that 0 is related to 2. That is, -3 related to 0 and 0 related to 2, but -3 into 2, which equals -6 and which is less than 0. That is, -6 does not satisfy. That is, -3 is not related to 2, and therefore we can say that A related to B and B related to C does not imply A related to C. That is, rho is not transitive on Z, not transitive on Z. Hence, we have determined rho is symmetric, rho is reflexive. Here rho is reflexive, and here rho is symmetric. Here rho is symmetric, but rho is not transitive. Here we have seen that rho is not transitive. So rho cannot be an equivalence relation. Now we will check the antisymmetry of rho. To check the antisymmetry of rho, let AB belongs to Z such that A related to B and B related to C, A related to B and B related to A. That is, AB greater or equal to 0 and BA greater equals 0, which implies AB greater equals to 0. Since in Z AB equals BA, but which does not imply that A equals B. So we can't say that A is an antisymmetry, because if we take A equals 2 and B equals 3, then AB get equals to 0. So hence we can say that rho is not an antisymmetry. Symmetric relation. Rho is not an antisymmetric. Okay. Therefore, by the definition of antisymmetry, we know the definition of antisymmetry as that A related to B and B related to A will imply A equals B. If this they will imply A equals B, then we can say that rho is an antisymmetry relation. But here AB get equals to 0 does not imply that A equals B. If we take, for example, if we take A equals 2 and B equals 3, then 2 into 3 which equals 6 and which is greater equal to 0, and 3 into 2 which equals 6 and which is greater equal to 0, but 2 and 3 are different. We can't say that, which does not imply that 2 equals 3. That's why rho is not an antisymmetry. Okay, so in the next video I will solve the question number 3 and 4 of example 1 of question number 1, because the video is getting lengthy to solve. If I solve the next questions in this video, then I can't upload it, and therefore I have to finish this video here, and in the next video I will solve the next questions of question number 1, that is question number 3 and 4. Thank you.